In the name of God, my name is Mehdi Kortnavasi. We are talking about the enterprise architecturing concepts. In this movie, we are starting with the key scenarios. The key scenarios are those important that are considered the most important scenarios for the success of your application. Key scenarios can be defined as any scenario that meet one or more of the following criteria. The first, it represents an issue, a significant unknown area or an area of significant risk. Key scenarios refer to an architecturally significant use case. We will describe in the following section about the use case. It represents the intersection of quality attributes and functionality. We will also talk about these subjects in the future. It represents a trade-off between quality attributes. Architecturally significant use cases have an impact on many aspects of your design. These use cases are especially important in shaping the success of your application. They are important for the acceptance of the deployed application, and they must exercise enough of the design to be useful in evaluating the architecture. Architecturally significant use cases are in two groups. The first is business critical. The use case has a high usage level or is particularly important to users or other stakeholders when compared to other features, or it implies high risk. The second is a high impact. The use case intersects with both functionality and quality attributes or represent a cross-cutting concern that has an end-to-end impact across the layers and tiers of your application. An example might be a create, read, update, delete, or CRUD operations that is security sensitive. Let's see a short movie about 3 minutes. What is a use case?
Designing a proposed information technology or IT application can be a daunting challenge. Whether you're tasked with defining a brand new application or making changes to an existing one, an immense number of decisions await you. One of the very early and critical decisions you have to make is how you will represent the requirements that the solution must fulfill. Ensuring that both the business community and the developers share a common understanding of the requirements is notoriously difficult. Any standard method for structuring the communication between these two parties drastically reduces the probability of miscommunication with all of the related costs and misery. The use case paradigm is one specific method that you should have in your repertoire of tools for representing how the proposed application should interact with the external world. Use cases were introduced as a method for defining requirements for IT solutions in the late 1980s by Ivar Jakobsen, and they spread like wildfire. Like all great techniques, practitioners have modified, augmented, adapted, and otherwise refined the basic concept over the years, and most of the add-ons are valuable in the proper context. Regardless of the context, one of the common pillars of all use cases is that they define the interaction between two or more entities, called actors in use case parlance. This correctly implies that the use case paradigm is not well suited for defining systems lacking interaction, i.e. batch processing. To address the communication issue, a use case is often presented in plain text and as a diagram. The use case description represents the interaction between involved actors textually at an appropriate level of detail. The use case diagram is a visual representation of one or more use cases depicting the actors, stick figure symbol with the name actor below it, and their connections, a simple solid line, to the use case, an oval with the name of the use case inside it. Due to the intentional simplicity of the use case diagram, it is considered optional in many organizations. It does, however, provide a great tool for representing the context of the use case in relatively intuitive symbols. The diagram is particularly useful if the use case involves a lot of different actors, which is often the case in embedded and real-time applications. Here's a very simple little exercise to demonstrate the
Use case. A use case is a methodology used in system analysis to identify, clarify, and organize system requirements. The use case is made up a set of possible sequence of interactions between systems and users in a particular environment and related to a particular goal. It consists of a group of elements, for example, classes and interaction or interfaces, that can be used together in a way that will have an effect larger than the sum of the separate elements combined. The use case should contain all system activities that have significance to the users. A use case can be thought of a collection of possible scenarios related to a particular goal. Indeed, the use case and goal are sometimes considered to be synonymous. Use cases can be employed during several stages of software development. The first, such as planning system requirement, validating design, testing software, and creating an outline for online help and user manuals. A use case or set of use cases has these characteristics: organized functional requirement, models the goals of system or actors or users, interactions, records paths or called scenarios from trigger events to goals, describe one main flow of events, also called a basic course of action, and possibly other ones called exceptional flow of events, also called alternate course of action. And the final is multi-level, so that one use case can use the functionality of another one. Let's see a short movie about how to create a use case diagram together.
Let's look at our automated teller example to see how we might start to capture the various use cases in a given system. So we'll start by drawing our system, and we'll call it ATM. And we will identify an actor who wants to interact with that ATM, and we'll call that actor the customer. So what goals might a customer have in interacting with an ATM system? Let's see what use cases we can identify. Withdraw cash. The customer might want to make a deposit. Customer might want to check the balance in an account. And the customer also might want to transfer funds. You might be able to think of a few more, but these will suit our purposes for now. So in each of these cases, the customer is the primary actor who has these various goals in interacting with the ATM. So to show that, we want to make an association between the customer and each of these different use cases. Now, looking at that, we might want to ask, who else interacts with an ATM? And it doesn't take very long to think of another actor. For example, somebody has to perform maintenance on the machine. So the way to phrase the use case, the goal that the maintenance person might have in interacting with the machine could be something like perform routine maintenance. Now the maintenance person, not the customer, is the initiator of this use case, so we'll indicate that by drawing the line from maintenance to the maintenance person to the perform routine maintenance use case. We have an association between this actor and this use case. And also, when you think about it, the customer can't withdraw cash unless somebody puts cash in it. We'll call that person the stalker. And the stalker's goal is to fill ATM with cash. And again, there's an association that indicates that this actor is the primary actor in this use case. So now we have our system, we have 3 different actors we've identified, and we have various goals that are associated with the different actors. The next thing we want to ask is there any other actor that comes into play in order for a particular use case to successfully finish? And if we look at these, the customer use cases, withdraw cash, deposit funds, check balance, and so on, for each of those, we do need a secondary actor. The ATM needs to talk with the bank system in order for each of these goals to be achieved. So we also have associations from these use cases to the secondary actor. Now, sometimes it's helpful to identify secondary actors. Sometimes you don't need them. What you want to do is look at your diagram and ask, is this easy to understand? Is it getting too cluttered? Is it clear that the customer is the initiator here and that the bank system comes into play once the use case has been initiated? And in this simple diagram, that is clear. So one way that you can show this is to have the primary actors on the left side of the diagram and the secondary actors on the right.
Okay, let's see another short movie, 2 minutes, how to business process convert and show as a via a use cases together.
Use case diagram helps you determine the core functions of a system. But the question is, where do the use cases come from? Who can give you the answer? The end user? Although end user is the person who ultimately uses your product, very often their opinions are either too abstract or too specific, way too specific. In order to identify use cases from end users, you need an effective way to extract the useful ideas from them. Usually, these ideas can be found by analyzing their existing workflow. In VPUML, you can represent workflow by drawing business process diagram, and to visualize use cases using use case diagram. The best thing is that you don't need to draw the use case diagram from scratch. You can simply generate it from the business process diagram. Let's take a closer look. In a business process diagram, works that are performed within a process are drawn as tasks. By studying these tasks, identify those that require computerization. Select them. Then, let VPUML generate use cases and actors for you. Finally, complete the use case model by creating other actors and use cases. Finished. You've now got a complete use case model that can help determine system functions. And best of all, you can always navigate right back to the originated task. Try Create Model today. Questions? Please feel.
Okay, thank you watching for this movie. and we are going to continue the software architecture and design techniques in the future movie, starting with the application overview. Thank you.